There are two main types of credentials that are commonly used in access control systems: 125 kHz proximity and smart cards. But what is the difference between them, and how does each one work? Prior to 1975, all card identification systems relied on magnetic stripe cards. However, as these required physical contact between the cards and the reader to work, eventually one or the other would wear out and need to be replaced. In 1975, radio frequency identification (RFID) was invented. This technology allowed a string of binary code to be transmitted over radio waves so that the card no longer had to make physical contact with the reader in order to be verified. This meant that both cards and readers would last much longer before wearing out. The technology was known as 125 kHz proximity. The 125 kHz refers to the radio frequency at which the signal is transmitted from the card to the reader. Each proximity card is pre-loaded with a string of binary code that is unique to the card in that system. When the card is presented to the reader, that string of code is transmitted to the reader at the 125 kHz frequency. However, that is all that can be transmitted at that speed, and proximity systems can be vulnerable to attack. If the system requires more robust security or more information to be held on the card besides just an identification code, then more modern technology will be needed. Smart cards were invented to combat the vulnerabilities in proximity card technology. They can hold far more information than proximity cards, and unlike proximity cards, which are pre-loaded with a fixed ID code, can have their ID codes changed and reprogrammed on a computer. Another significant difference is the frequency at which the smart cards transmit information. Where proximity cards transmit at 125,000 Hz, smart cards do so at more than 10 times the speed, 13,560,000 Hz. This means that in the same time it takes for a proximity card to transmit a short ID code, a smart card can transmit much more information and implement additional security measures to protect the information. The most important advancement in the technology inside smart cards is the addition of authentication. This means that before transmitting the identification code to the reader, the card authenticates the reader to ensure that it is part of the genuine system and not from an external attacker. Once authenticated, the ID code can be transmitted. At this point, the data is encrypted as it is passed from the card to the reader, adding a further layer of security, preventing external attackers from accessing the information being transmitted. The most common brand of RFID chips used in smart cards is MyFair. It is estimated that 1.2 billion people around the world have access to a system utilizing MyFair technology. MyFair chips come in 4 different families: Classic, Plus, Ultralight, and DesFire. CDVI offers reader and credential solutions utilizing MyFair Classic or MyFair DesFire technology. MyFair Classic is commonly used for accessing control systems that don't require a high security solution, such as corporate office buildings or gym and leisure facilities. The memory inside a MyFair Classic chip is essentially just a storage device divided into sections and blocks for different parts of the data. MyFair DesFire is the highest security family of MyFair chips. The DES refers to Data Encryption Standard, a block cipher of which there are 3 subtypes used in MyFair DesFire chips in the EV1, EV2, and EV3 versions. MyFair DesFire also benefits from AES encryption. The FIRE is an acronym standing for Fast, Innovative, Reliable, Enhanced. As the most secure family of chips, MyFair DesFire is ideal for systems that require identities and personal details to be protected, such as touch-free payment cards or high-security access control.